Hi, this is Mrs. Clark, and welcome to my video on the angle addition postulate, and we're also going to be going over angle bisectors. So once you fold your paper in half, you're going to want to cut along the dotted line so we end up with two little doors. First thing we're going to look at is the angle addition postulate. If you'd like to color the outside of this, you totally can doodle here. If you want to, it's meant for that. Alright, so starting with angle addition postulate, it's going to be very much like the segment addition postulate that we looked at when we were doing lines and segments. To look at this, first we're going to look at the definition. So very much like the segment addition postulate, angle addition is kind of a very common sense statement. It says if K is in the interior of angle HIJ. So first let's look at HIJ. You may want to grab a couple highlighters for this. HIJ is this angle here, HIJ. And so we know based on the segment addition postulate that the measure of angle HIK, sorry, I just highlighted that the wrong color here. Let's change that. The measurement of angle HIK plus the measurement of angle KIJ is going to equal the measure of angle HIJ. So I'm going to use three different colors here. So when we're looking at the picture, HIJ is this whole piece. This little M that we see in front of the angle sign on all of these, that means measure. So make a little note of that. The measure of. Okay. The measure of HIK, so let's look at which one is HIK. HIK is this angle here. We look at the measure of that angle, which appears to be acute, and we add it to the measure of KIJ, which is this angle, which in this case also appears to be acute. They should be equal to the measure of HIJ, which is this outer angle. So this small angle plus this adjacent small angle is going to equal the measure of this whole angle. And that's what our segment addition postulate is telling us. And that only happens if K is between this HIJ, or in the interior of. So it's not in the reflex part, it's in the interior of this angle HIJ. So if K is a point somewhere in the interior, or inside the angle HIJ, then you can divide it up into HIK and KIJ, and these two smaller angles add up to be this whole angle. That's what the segment addition postulate tells us. What that helps us with is doing an example like example number 1 here. So it says if the measurement of AOC equals 70 degrees and the measurement of angle AOB equals 1/2 parentheses 2x plus 20 degrees, and the measurement of angle BOC equals x degrees, find x, find the measure of angle BOC, and find the measure of angle AOB. So we're going to have to solve an equation here to find ourselves what x is equal to. But before we can solve an equation, we have to set it up an equation. So what we need for an equation is something like this. We need to look for two smaller angles that I can add up to equal a larger angle. So if we look at this diagram, I'm going to start filling in some of the information that they tell us. It says the measure of angle AOC is 70 degrees. So AOC is this angle here, AOC. So that's our outer angle. And we're told that this is 70 degrees, so I'm going to mark that. I'm not going to write it in here or in here because that's going to get confusing with those inside angles. I'm going to mark it kind of over here, saying this whole measurement is 70 degrees. And then we also know the measure of angle AOB, which is this piece, AOB, is 1/2 parentheses 2x plus 20. So I'm going to write that here, 1/2 parentheses 2x plus 20. I'm not going to worry about how weird that looks with the fraction and the parentheses and all that right now. I'm just going to label what goes where. So that represents whatever x is. That'll help us figure out what AOB is. And then BOC is this angle. And that is just x. So I'm actually going to highlight these here to match the colors that I did. BOC is just x, so I'm just going to put an x here. So let me go back and highlight AOB in pink because that was the color I used for that. And then AOC was our green. Okay. So what can we make for an equation from here? Well, we know based on the second addition postulate we have over here, the two small angles add up to equal the big angle. So which ones are our two small angles here? Well, our first small angle is this pink one. So that's AOB. So I'm going to start by writing this letter equation using the angles. So the measurement of angle AOB, that's the pink one. If I add that to the measurement of this small yellow one, which is BOC, it should equal the measurement of the whole angle, which is AOC. So that's our letter equation, kind of like how we were doing the segment addition equation. There's our angle addition equation. So that would be like our criterion C communication piece. And then underneath that, I'm going to fill in the numbers and expressions that I have represented for each of those angles to help build an equation that I can solve. I can't figure out what x is until I make an equation. So if you want to color code it, it goes like this. AOB plus BOC equals AOC. Now if I follow those exact colors, I can fill in all the pieces that go right underneath it. So this little fraction in parentheses thing is going to go first. So 1/2 parentheses 2x plus 20. And I'll help you through this part later, so don't worry about that. Plus, because we're adding the two angles, BOC, which is just x, so that's easy, equals, for my equation, the total angle, which we know is 70 degrees. So up here, I'm writing my letter equation. Down here, I'm writing my algebra equation. Now what we need to do is solve this equation to figure out what x is. Once I know what x is, I'll know I can figure out this yellow angle and this pink angle. Alright, so let me help you through how to find x. First thing we need to do is get rid of our parentheses by distributing. So if you remember, don't call me after midnight, we start with distributive property. So that means I have to do 1/2 times 2, 1/2 times 20. So when you're taking a half or multiplying a half times something, you're just taking a half of it. So what's a half of 2? 1. So I'm left with 1x. What's a half of 20? 10. So I'm left with positive 10. So my parentheses go away when I do a half times 2 and a half times 20. Half of 2 is 1, so 1x. Half of 20 is 10, so plus 10. So parentheses are gone. Now I have plus x equals 70. I just copied the rest of the equation down. That is much easier now to try to solve now that my parentheses are gone. So don't call me after midnight. I've done distributive property. Next comes combining like terms. So I've got 1x here and I've got another x there, so that's a total of 2x. I'm just going to stick those together. 2x plus 10 equals 70. So don't call me. It means move the variable, but I only have variables here, so I don't have to do that. After midnight, so I'm going to do my addition first, then my multiplication or division. So I see it's adding 10 already to the x, so now I'm going to do the opposite and subtract 10. And I'm going to subtract 10 on the other side of the equal sign under the 70. So now I've got 2x, that's 0, equals 70 minus 10, which is 60. And my last step is to undo my multiplication or division. 2x means 2 times x, so I'm going to divide by 2. X equals 30 degrees. So x equals 30 degrees. BOC is x, so that also equals 30 degrees. AOB is 1/2 times 2x plus 20, which I can do, or now that I know this is 30, if you think about it, 30 plus what gives you 70? 30 plus 40. So AOB has to be 40. If you wanted me to show you how to put in the 30 here, this is what you would do. 1/2 times 2x, instead of x I'm going to put 30 plus 20. So I would clean up my parentheses first. I would do 2 times 30 and get 60. So it's 1/2 of 60 plus 20, which is 80. 1/2 of 80 is 40. So that's where we can confirm that our 40 is correct. So we wrote ourselves, first of all, we filled in our diagram with what we were told in the problem. We wrote ourselves a letter equation that follows our angle addition. We filled in all the x's underneath to get ourselves an algebra equation. We followed Don't Call Me After Midnight to solve our algebra equation for x. Once I knew x, then I put x into both of these expressions to figure out the angle BOC and the angle AOB. And now we're going to look at an angle bisector problem. Right, so looking at angle bisector, a bisector is the same thing for an angle as it is for a segment. But in this case, because it's bisecting an angle, it's a ray instead of a ray or a line segment or a line. It's a ray coming out of the vertex, and what it's doing is dividing the angle into two congruent angles. Remember, the word congruent means equal. So, if XZ is an angle bisector of angle WXY, name the two congruent angles that it forms. So if we think about this angle WXY, that is getting cut in half by this angle bisector XZ. And so that means this side is going to be the same as this side. So what are the names of these two angles? Well, I have this angle. It's going to be the same as this angle. So this side, the pink angle, is WXZ, or you could call it ZXW. So angle WXZ. And notice it used the word congruent. The symbol for the word congruent is a squiggly like tilde, like you'd use in Spanish, over an equal sign. The green angle is ZXY or YXZ. And remember, this symbol means congruent. So write the symbol and also put the word down so you know what it means. So angle WXZ is congruent to angle YXZ. And putting these little tick marks on here shows that they are the same measure. So if I find one, I'll know the other. So let's do this quick example that will help us find the measures of x and then the measures of all of these angles. So first we know that FG bisects angle EFH. It's very important that we mark this down first so that we don't get confused as to which of the angles are the ones that are equal. So EFH is what's being divided in half. So EFH is this angle. So notice I just traced EFH. FG is what's dividing it in half. So there's your bisector, which means that this is going to be the same as this. So that means the two angles that are the same are EFG and GFH. So let's keep reading and see what more information we have. If the measure of GFH, now that's one of the ones I just said, is 1/2 times 10x minus 20, even though that looks scary, that's kind of like the one we just did, so it shouldn't be too bad. GFH is this one. I'm going to put it here. 1/2 times 10x minus 20. And the measure of EFG is 3x plus 25. Well, that's going to go in this one, EFG. 3x plus 25. Then I have to find all of these things. So first I got to find x, so I got to come up with an equation. We're not going to use the angle addition postulate here because I don't have a total for any of these angles. But I do know that this pink angle, EFG, is the same as GFH because we have an angle bisector. So my equation is going to say measurement of angle EFG equals the measurement of angle GFH. So just like in segments, we have to decide, are we adding up segments or are they equal to each other? When they're equal to each other, we can write our equation like this. So if I go to fill in my algebra equation, I'm going to say 3x plus 25 goes on this side equals 1/2 times 10x minus 20 for the other side. And so we need to solve this equation now to figure out what x is, and we'll be able to find those other angles. So we're going to use our don't call me after midnight. We're going to get rid of our parentheses first. Don't call me after midnight. So first we're going to distribute. I'm not going to do anything with this 3x plus 25 part first. But I'm going to do 1/2 of 10x. So half of 10 is 5, so 5x. And then half of negative 20 is going to be negative 10, so I'm going to put minus 10. So 3x plus 25 equals 5x minus 10. 5 came from half of 10, and negative 10 came from half of negative 20. So we've done that. Now combining like terms. Over here I've got a variable and a number. There's my equal sign. Over here I've got a variable and a number. I can't combine these. I can't combine these. So we're going to go to the next step, which is M for move the variable. I'm going to bring the 3x's that are here to the other side of the equal sign with these 5x's. I cannot just combine them. I have to use inverse operations. Since this is a positive 3x, I'm going to take it away. So take away 3x. So subtract 3x from both sides. It's going to make those cancel out. And we'll have 25 equals 5 minus 3 is 2x minus 10. Then I'm going to go to do my addition or subtraction. Here's my x's. They're subtracting 10. So I'm going to do the inverse and add 10. I'm going to do that on both sides of the equal sign. 25 plus 10 is 35 equals 2x. That cancels out and is 0. Last thing I'm going to do is my multiplication or division to get the x by itself. I've got a 2 in front of the x, so I'm going to divide by 2. 35 divided by 2 is actually a fraction, or a decimal, I mean. It doesn't divide out evenly. So x is going to be a decimal. 17.5 degrees is our x. So I'm going to fill that in here. And then I've got to find the measure of GFH, EFG, EFH, and IFE. So to start, I'm going to look for the two that are equal. I'm going to skip this one because it's a little bit harder to plug into. I know it's going to be the same as that one, so I'm going to do that first. And I'm going to figure out that one, and then this will be the same. So I'm going to do 3 times 17.5 plus 25 to get GFH and EFG. They're going to be the same. So 3 times 17.5 is 52.5 plus 25 is going to equal 77.5 degrees. So this is 77.5 degrees. This is 77.5 degrees. Then I have to do EFH, which is just both of those added together. So I'm going to do 77.5 plus 77.5, or you could do times 2. And that's going to be 155. And then I've got to do IFE, which is this other side. So now I got to think about, if I know this piece is now 155, how would I figure out this side? Well, if I draw like a little mini equation for you, or a little mini diagram over here, a little bit more to scale, we basically have this. I'm looking for this. So we know this side is 155. I want this side. Together they make a straight line. So I'm going to do 180 minus 155. Get 25 degrees. So IFE is 25 degrees. So that was a lot in one problem. But just to show you how each of the things that we're doing kind of build on each other. We're using the algebra that we worked on from last unit, or last part of our unit. We're using the angle equations that we've learned when we talked about bisectors, and finding our x, and then we're just substituting our x's in to find the angles in the diagram. So once I know just that piece of bisector, I could find out each of those angles, this whole angle, and that angle over there, just by knowing all of those pieces that I've learned so far. Let me know if you have any questions. Make sure this gets glued into your notebook. Start working on your angle addition practice, and then I'll be able to answer questions as you have them. Thanks for watching.